So last class, we saw that Java 8, how like basic about why we are going for Java 8 and how are we gonna advance our coding standards using Java 8. So it is like just enhancement in our coding style and nothing much more than the concept part. There are few features they have enhanced, but on top of that, we are basically focusing only on the latest enhancement provided by the Java 8 on the functional programming style. So since you were not present, I'll just recollect the topics once and we'll go forward once.
Okay.
Okay, let me share my screen. Are you able to see my screen?
Yes, Neha, I could able to see.
Just a moment, I'm getting a call. Yeah, sorry. So the basic thing is we have a concept called functional interface. So you remember why we go for interface?
Yes, Neha. Like instead of that extends, we will go for the interface
No, that is the way we implement. But what is the purpose behind our interface?
for multi-level inheritance.
The same thing you can achieve through inheritance as well, right? But why specifically interface?
I mean, two parents and single child cannot inherit
Yeah, that
that,
is
right?
okay.
That
Then
is a
what
big
else you can achieve through inheritance? Sorry, interface.
interface. We can just define the structure, but no need to declare anything. I mean, we can declare, but no need to define
Yeah,
anything.
exactly. So we don't need to define our logic. We can just define, and wherever we are implementing that interface, we actually write our own logic, right? So
Yes.
in Java 8, what they have given is they have enhanced the feature by giving few more add-ons. The first thing is like earlier, all your methods which you define within your interface are public, right? You can't define static methods or you can't define default methods.
Oh, yes,
Remember?
Neha. Yeah, yes, yes.
So whatever we define, this was the structure. If you give private or something like that, if I say private void p2, right? I can immediately see the error that only public, abstract, default, static, and strict FP are permitted, right?
Oh, yes, Neha.
So
Yeah, this
this is
one.
Java 8 version. So if you see in your code, if you just type like static method or any kind of default default in usual way, we never have this keyword. If we don't have any keyword, then it is said to be default. This is what we learned so far in access modifiers. So in interface, we can define only the public methods, not private, static, or final, or any kind of other methods inside your interface. But in Java 8, they have given a feature that you can build your own static methods and your own default methods, and you can use it in your child classes. So how does that be a better solution is, in your abstract class, you usually write your concrete methods as well as your abstract methods. So if you have abstract method, then you have to inherit that one in your child class and write your logic and use it. This is what abstraction does in normal abstract class. The second thing is, if your method is concrete method, you write the entire logic in your abstract class. So you write like abstract and then the relevant method, say P2, and you give this. So what you do, this particular abstract method logic has to be written in your child class. But if you have your own method and it has to be reused in all the places, you just write your logic public T2 and you write your entire logic, everything here, and you just call this method from your child class. So it is a reusable method. So all the child classes can use it. This is a feature in your abstract class. But in interface, this was not possible earlier because we can only define or declare, but we can't give the logic here. That is what the interface was giving us earlier, right?
Yes, Neha.
So, but now in Java 8, what they're saying is, if you have any kind of default behavior and that has to be commonly implemented in all your child classes, you can actually use a keyword called default and write your entire logic, and all the child classes can have the access to this particular method. Okay. And the second thing is, earlier the static methods were not possible in your interface, but right now you can have your own static method. And what is the benefit of having static method? You don't need to create an instance. Instead, you call it directly with your interface name or class name, directly the method name. So it will be like fun inter.test3, right? If it's a static method.
Yes, Neha. No, we will not create
We will
object. We
not
will
create
call
an
directly.
yeah. So these are the two possibilities in Java 8 we have achieved from our interface concept. So what we do is, say this is test 2 and this is test 3, and I have created fun inter, and here if you see, I have created this fun inter Java class which implements this particular one, and I have overridden the usual abstract method. And in the second method test 2, this test 2 is nothing but my default method. Okay, so you can still override this behavior in your child class. It is possible. If you don't override, it will take the behavior from your interface. If you override, it will take the behavior from the respective child class. And how do you create your object? So when I create an instance, so while we creating the instance for my child class, and from the child class, when I call test1, the test1 is a public method, so I have to have the implementation in my respective child class. So you will get inside class test1. So the second object is test2. In your interface, it is actually default. So what happens if I comment this part, and if I execute this test2, I should get only default interface method. The third thing is funinter.test3. So the test3 is a static method, right? You don't need to create any object here. So though you create your, so what did I do? I used my interface reference name, which is the interface name, and I'm directly calling that interface without any object. So if I run this, this would be the place. So if suppose, if I need to override the default method, then what happens? Test2 default method will be overridden from the respective child class. So this is the same thing we achieved in our abstraction too. Then what is the benefit of this? The main benefit is in your abstract class, the same thing. You can't extend more than one class, but in interface, you can extend more than one interface. So in that case, if you have default methods, you can override in the respective child classes, and even you can reuse them again and again by extending multiple interfaces in all your child classes. That is the thing. They bought this abstraction concept within the interface. So earlier it was like partially abstracted. Now it is fully abstracted.
I mean, earlier also, like whatever we have declared in the like parent class, it can be used in n number of child class, right? Like when we do.
Yeah, it can be used in a number of child class. See now, what happens if you use test1 here? Wherever you create your child class and implement this interface, you have to write the logic for test1.
Yes, yes.
Now what happened? I didn't create test2 here. I'm just overriding if required. Otherwise, I won't write my logic as I do for test1.
Okay.
I'm using the common logic, which is available here. Again, common logic through static method in my interface. So what is happening earlier, if you have these methods like defined like this, you have to mandatorily override them and write your logic in your child classes, right?
Yes, yes.
So now you don't have a need to mandatorily override it. Instead, you can actually write the reusable codes in your interface itself, and you can call them in the respective child class. So the
Yeah,
same thing
understood.
you achieve in your abstract class, the same thing is happening here. Nothing much difference.
Okay.
Okay. This way your abstraction logic is being fully abstracted through your Java 8 interface, where they have introduced an add-on called default methods and static methods. Okay. So when you want to write your static methods and interface in less than Java 7 version, that was not possible. But now it is quite easy for us to access and implement. So whenever you have reusable methods in your interface logic, then you can simply go and write static or default, and the respective object, how do you create in your execution, like whether you give type reference with interface name this and then equal to new child class, or directly child class object, however you create your instance, the relevant methods can be called. Okay, so any questions so far?
No, Sneha.
Okay, so this is the normal interface, but in Java 8 they bought something called functional interface. Okay, what is this functional interface? The main concept behind this functional interface is so usually all the methods in your interface are public, right?
Public. Yes.
So by default, they're also all abstract methods. So they're nothing but abstract and public methods. So the functional interfaces, you should have only one public abstract method. If you have only one public abstract method, then that is called as functional interface. If you have more than one public abstract, so if I have a similar one like this, and I say test 2, okay? So if I have more than one interface, you can't make this as functional. So see, invalid annotation, it is not a functional interface. So what does that mean? Your functional interface can accept only one public and abstract method. And if you use this interface, it means like you can have only one, not more than that. If you're trying to do this, then you have to comment this annotation. Okay, so the functional interface is like, it is like I can have only one, not more than that. If you try to give me more than what, I'm not ready to handle it. This is what the behavior of functional interface. But how can we be dependent on this functional interface? How can we use this? This is the question. So we'll see that right now. Okay. So did you understand what is a functional interface at least now?
Yes. Like to handle more than like one public and abstract
No,
method,
no,
we
no, no,
will.
only one, not more than one. If I
Okay.
give more than one, it is returning me error, right? Invalid
Oh,
interface. So a functional interface can have only one public abstract method.
okay. Okay.
Okay. But in the usual interfaces, right? Usual interface, you can have any number of methods as public and abstract. Okay. That doesn't give any problem. But if you're making your interface as functional interface, you can have only one public and abstract method, not more than that. Okay. So if you see the real-time example, you remember the comparable and comparator interfaces, which we learned earlier to do sorting and natural sorting.
Yes, Neha.
You remember or you forgot? Tell me
No,
something.
no, I remember that term, like we like you explained like for what purpose we use that comparator and yeah.
Yeah, exactly. So what happened is, let me go to that comparator. So the method you have in this interface, right? There are multiple methods here, right? If I go with this comparing double, this is static method. If I go for null first, that is again static method. If I go for then comparing, it is again default method. If I go and see the actual method which is compare, that is the only one method which doesn't have any keyword as public or static or anything, or private or default, only method. Okay. If I see the other methods, if I say equals, it is a different method to get overridden from your top class object. Other methods, for all the methods, you see either default or the static keyword in your comparator class. Why so? In that case, if you see in your comparator class, you can see an annotation called functional interface. This means like I have only one public abstract method and rest all methods are default or static. It can be anything, but my system accepts only one abstract method. So what is the benefit of having such one abstract method, and that is called as functional interface methods? What is the main benefit of this? So the thing is, there is something called as lambda programming. Okay, so lambda program. So what is it? And how these functional interfaces are related to it. That is what we're going to see. So Java 8, the main purpose of the Java 8 is, this has a concept called functional interface. Okay. And then it has expanded the things called as stream programming using lambda expression. So why we need to learn this one? The main benefit is whenever you write a program in less than Java 8 version, whatever you do, the iteration or use for loop or everything, you need to use at least, if you go for iterator, list iterator, what happens? You iterate your list, one for loop list, and you get it the relevant list instance. And here you do your iteration, the logic, entire thing, and then you come back. So minimum of 4 to 5 lines based on your logic. Okay, I don't know the logic lines, but apart from that, you see there is like 3 to 4 lines of code you're writing to execute your simple program. But what is the functional interface or the lambda expression is giving us a freedom is you can minimize the line of code, okay, in less than a. So for example, if you're doing this for loop and you're printing, you're streaming the next value and you're printing it, then it happens with 4 lines. But in stream, when you use lambda expression or streams, this can be easily written in 1 line. Okay, that is basically shortening the entire way so that it's making the developer's life more easy. Okay, so before going there, how is this lambda expression and functional interface are related? So now you know what is functional interface. Can you tell me what is a functional interface?
It can have only one that abstract method, abstract with public.
Yeah, one public abstract method. Correct. So now, what is lambda expression? So have you seen any JavaScript code before?
No, Sneha.
Okay. So what happens is Java is tightly coupled, right? So and tightly coupled as well as strongly coupled, strong data types. So we can say tightly coupled and it has a strong data type. Okay, so what does that mean? So whenever you create an integer variable, you give the relevant data type and x equal to 8. If you're creating a float, you say float f equal to and give 0.8. Yeah. So whatever you define, you are actually binding it to the relevant data type. So it is a strong data type. It can't accept any other thing. So if you're suppose giving here a double value, will it be able to accept?
No.
Sorry?
No, it will not accept.
So what do? Usually we typecast it to double and then we return it, right? So whenever we wanted to typecast or if we want to typecast to float, we typecast the relevant value to float and then we return the data. So the Java is very case sensitive or type sensitive. So you can't actually give different data when you're defining a relevant data type. So to break this model, the lambda expression is brought in. So what it's doing is you give me some variable x equal to and give me any kind of data. I'm ready to accept any data type. I'm not like tightly coupled with the data type. You can give me any data. I consider, I accept, I understand, and then I identify which data type it is. I'll take care of it going forward. You don't need to tell me what data type it is. I'll take it. So this is what Java 8 is giving us a freedom. So this is already present in our JavaScript. Okay. all the Python, JavaScript, everything is feasible for us to give like this. If you go for any Python programming, you can go and just give some variable x equal to some value. You don't need to say any data type constraint. But in Java, we have to say that because Java system is designed in such a way where you can't give any data value with any data type. So there's a conflict happening. To resolve that, in Java 8, it is helping us to go with this kind of programming called functional programming. It's just a advanced level of implementing the coding style. That is the only thing. So that is, it's not making more difficult the developer's life of every time casting it, reconverting it to the actual data type. Okay, so everything is taken care by our JVM itself from Java 8. So what is happening is, say if you have a method, let's say sum. Okay, I'm just going with a random sum. So if I have two numbers to be added, what do I do usually? I create a method, and then parameters is with that what type am I going to accept it, and then the return type of that particular method. So every time what do? I provide the data type, right?
Oh, yes, Neha. Yeah, yes, Neha.
Yeah. So every time we provide the data type, so that only then the system was able to accept. So to overcome this, we got something called generics, which was giving us the feasibility, like you don't need to give me the data type, you just tell me the sum, and then use the any type of data. You can pass me any type of data, I'll do it. So this was one advantage given in Java 7 and before, after 1.5 version, as generics, where you can define your structure like this and it can still accept it. So if you see the comparable interface, right, you are able to see this one, right? It is accept to any type of data. So this was open, but still you need to pass this, right? You need from, so wherever you create your object, if you're creating a comparator for employee, then you have to pass here employee. If you're creating a comparator for library, then you're going to pass that library object here, right? So whenever we are creating it, we are passing it. But in Java 8, it is telling me that I don't need to know what type you're going to pass also. You just randomly give me this one, say just a comma b. I'm okay to accept anything. I'm okay to perform that sum and return you the value. Okay, you don't give me any data type, I'm okay to accept it. So it is making the way of defining more easy. Okay, so this is represented like whatever parameters you're going to pass. So it is basically working only on two things. One is your input, the other one is your output. You don't tell me what data type, what action you're going to do. Tell me what are the inputs you're accepting and what is the logic, and finally what is the output you wanted. So the structure of this one would be like how many parameters you're expecting, and this is the representation. This is nothing but a representation of lambda in our Java. So it's a notation which we use to write our lambda expressions. So what all parameters you write and the relevant pointing it to what it has to actually happen. What is the action it is going to give? So it is like action or a body, okay, where you're going to write your entire logic. That's it. This is the representation of your lambda expressions. Okay, so till now, any questions here so far? Like why it was tightly coupled and how it has been generically moving with one or the other concepts, and where are we now? So why the lambda created?
It's clear, Neha.
So you have no questions so far, right, in this?
No.
Okay. Okay, so let's try some sample examples of lambda so that we'll get to know how to represent our lambda expressions and why this functional interface is much more needed there. Okay, so let's go to our interface, which we have here. Okay, so I already declared it as function interface. Okay, so it means that I should have only one abstract method. So let me go to the relevant child class. Um, So give me some use case, like what, for which one we can go and create lambda expression.
So lambda expression in sense like for that function override kind of thing you are asking?
No, no. So the thing is, the whatever we represent through function interface is like, it should have only one abstract method. But how do I access it? How do I make my life more easy by, instead of not creating an object or not creating a reference and calling the relevant object, I want to make it more simple. Say in your comparator interface, you had only one compare method, right? Compare to, which was the only public abstract method, and which was accepting how many parameters in it?
One parameter.
One or two?
One,
Two.
two.
Okay. So what is doing? It is returning me int, and then it is accepting two parameters of any data type. This is the only abstract method and public method I have here. So the two parameters I have is compare to method, which accepts two inputs. Okay, that is n1 and n2, and it is giving me one output. Right? How will I represent this comparator one? Using my lambda expression. So lambda expression, what does it tell? It tell me the parameters and then the body which I'm gonna call. So as per my scenario, what are the two, let's say the parameters x1 and x2. Okay, these are the two parameters. I'm gonna use the notation of lambda, and within that, what am I gonna use? I'm gonna use this method called compare. Okay, so I'm gonna say compare. That's it. And what is it written? Integer. That's it. It will take care of everything. I don't need to tell anything explicitly on top of it. Okay. So we'll see how this can be done. Okay. So before that, how can we represent our lambda in a more better way? So if you have parameters, okay. If you don't have parameters, so first we'll go with no param. Okay. So you're not giving any parameters to your action method or a body which you're going to call. Then you just give default, and then you use this notation, and then within that you write your logic. So where you have your body part, okay, whatever you're going to action point you're going to do. So when there is no input for your method, so similar to compare, if you have some other method which is not accepting any input, then you can represent your lambda expression in such a way. Okay, if you have one parameter, how can I represent it? The one parameter is x1, again the notation, and within open and close I have my action body. Okay, so how do I do it for two parameters? Can you tell me?
Parameter x1, x2. And we should perform the like whatever the operations you want. It should be inside the body.
Yeah, so whatever we want, we represent within this parenthesis. So what is this parenthesis? This is nothing but an anonymous block. So what is anonymous?
It is not known in prior.
Yeah, so if you're creating your own interface, right? So what do we do if you're using a comparator from compare to method? You create a comparator object, and from that comparator object you call the compare method, and then you use it. Now I'm not going to create an object itself. I'm directly going to call compare method. Within which one? Within that block, within this block. So it means like I'm creating runtime object. I'm going to call that class, I'm going to call that method, but I don't want to create any object. Okay, so this anonymous blocks help us to create the object at runtime, but it will not have any reference name. If you give comparator C1 equal to new comparator, you have a reference as C1. So your object gets created. But if you're not giving that, what happens? New comparator alone gets created, but it will not have any reference. Did you get my point?
Oh, yes.
So now, anyway, we have here this one, right? So usual way of representation for test one is, if I want to call this, I need to create an object. And after creating the object, I need to call this test one. This is the usual way. What I'm going to do now is I'm going to create another reference. Okay, let's say functional interface Java 8. This is going to be my reference. So I'm just creating let me create this as Java 7. So this was before reference. Okay. Before Java 8, we were using this. So now I'm going to create my object in Java 8. So using what? Lambda expression. So now to this method, fun inter, do I have any method or parameters in this method?
No.
Do I have any return type?
No.
So what do? I go here. This is usual reference we do. Now what should I do? I need to create my lambda expression. Since I don't have parameter, I'm giving an empty one and followed by your lambda expression. This is the one. Okay. And you have to close this. Okay. I'm done with this. So what I'm going to call here. So since this method is returning nothing, what would I do is here I have inside class test1, right? So I'll just copy this. Since this particular method is returning nothing, I can't return there. So I'm going to print the same sys out and inside say here inside test1 lambda. Okay. I represented that here through that particular method of test1. I'm done with it. Let me create this as int. Let's see what is it. Just a moment. I'm just noting what is the error here. So did you have any questions so far in this?
No, sir.
Okay.
Oh, you said no parameter, right? So for that also we will have the action body or will not have action body action.
No parameters, but you have an action, right?
Okay. So we will have action body for the no parameters also, right? The only thing is we won't pass any parameter for that.
Yeah, true. That's it. So this is also called a single abstract method because you're going to have only one abstract method here, right? So they call it as SAM. Okay, it's also a single abstract method. So like whoever says what is lambda expressions or what is functional interface, you can say SAM. It's a single abstract method. Okay. So I'm not sure why this is happening. Let me try this and then I'll come back there. So we know array list and we know the comparator, right? To compare the data. So we'll try with that itself once. Okay. So how do we add here data?
List.add.
So last class, Kiruba had few queries on few concepts. So he wants us to rediscuss on that, okay, to have a revision on it. So if you have any other topics that need to be discussed or you want to revisit that, tell me that list. So we can actually sit tomorrow and recollect them before going to the next concepts.
Okay, sir. I'll have a look and I'll get back.
Yeah, sure. Okay, so now if I need to use sort, what do? I just give collections dot sort and it will ask me either what type of thing you want to sort it out, right? So now here, what should I pass? A comparator object, right? So the sort is accepting list object and a, sorry, you there?
Oh, yes, Neha.
So what is accepting?
Comparator.
So what is comparator? This is nothing but your actual comparator class. Let me open it. You were opening it here, right? From long time. Where did it go? So this is nothing but your functional interface where you have your compare method which accepts two parameters. So you know this is an abstract method and that is the reason we are using functional interface. So how can I represent that here? So what are you going to compare? You're going to compare two objects in terms of your comparing method. So how can we represent that? We represent this with the parameter annotation followed by your logic within the body. So how many parameters is my comparator accepting?
Two parameters.
Two parameters. So what are those parameters? It can be anything, right? It can be string or anything. Since we have given list, so I'm going to give it as string and string. Okay. So these are my two parameters. So what is the logic I need to do here?
Call that compare method. Right?
So the compare method I need to call. So how do we call usually? How you want to compare the data? So I need to give some reference. So let me say string A and string B. So I'm going to call this on comparing the data set. So what I'll do, A dot did I miss anything here? So how do we compare here? Some string dot compare to the other string, right? So here, what do we usually do? We create our own comparator class. We override the compare method with the string object, and then we do it. But what happened now? The entire logic is written in single line. Do you see the difference?
Obviously.
So what do we do usually in the earlier way? If you wanted to do this collections.sort, it accepts some comparator object. Okay, let me just quickly open some real-time comparator. Okay. Comparator 7. So in Java 7, how do we write our logic? We create our own class, we implement that comparator, and then we override the logic here, and then we create an object. After doing it, we use that object and we pass that object. So they were like 5 to 6 steps, right, for us to do this implementation. Are you there?
Oh, yes, Neha. Yeah.
So
Yeah.
what happened here? So we were creating explicitly a separate class and then explicitly overriding it. And then we are calling it by creating our own instance.
Object.
Instead, what did we do now? We didn't create any instance. We have our own object created at runtime. So we know the number of parameters. We know what action you're going to call. So if it is a single line, you don't need to give this parenthesis. Okay. If it is single line, you don't need to give. If it is more than one line, right, you have to represent that within the curly braces. So if you have compare and you have multiple steps in that logic, orchestration logic, then you have to write everything within that parenthesis. If you don't have such thing, in that case, what you can do, you can just represent that in a single piece of line. So what happened is our the developer's life is being become so easy that you need to know whether that is a functional interface or not. So you can refer that through this one, and then you know this is a this is a functional interface method. So in that case, I go there, I represent that through my lambda expression, and then I use it. So all your functional interfaces can be used through lambda expressions. This is one way to use it. Till now, any questions?
Only functional interface can be expressed in terms of lambda, or anything can be expressed in lambda.
Mostly the functional interfaces alone will be used through lambda. There is something called streams. You can use that, but the functional interfaces and lambda are kind of relation. So wherever you have this functional interface, how do you access them? You access them through the lambda expression. So this is the lambda expression. So lambda expressions are represented through the number of input parameters and then followed by the actual output. So you don't give that written or anything, right? You just give the action and then it gets executed.
Okay.
Any questions so far here?
No.
Just a moment, I'm getting a call. So any questions so far, Janaki?
No, sir.
Okay, so I want you to analyze and see how this function interfaces can be used. Oh, Kirba, you joined. I didn't notice it.
I just now joined.
Okay, fine. Okay. Yeah. So so we just saw the lambda expressions. Like what did we see theoretically last class? We just try to implement that right now through using our comparator interface for our list object. So let me run this. So you see your data got sorted out by using your Java 8 representation of lambda expression. So instead of writing like few pieces of code like this, like overriding the relevant methods and everything, Java 8 is giving a feature of writing everything in a single piece of code, so that it will be in a single line, so that in future if you want to compare, or if you want to change this comparison, or if you don't want the comparator, if you want to change to comparable, then anything can be possible only in the single line. So it is, the coding style is getting changed, and it is becoming more better than before Java 8. So that is the way we are using with lambda expression. So any queries here?
No.
Okay, so this is the one thing. So there is something called streams in our Java 8. So there are two streams. So I'm just giving an overview about the streams right now, because it's a wide concept. So we need to try a lot of samples using our collections. So before going that, what exactly the stream is? So you have heard the stream in your Java IO handling, right? So what is that stream in IO handling? Hello? You there?
So,
Yeah. So what do we handle in, what do we say as streams in Java IO handling?
streams, it's like real-time data.
The data which is in byte formats, right? Or any data which is in the byte format, we call it as stream. But in Java 8, the stream handling is a separate way of handling the inputs and outputs. So like for example, if I need to iterate this data, or if I need to filter data which is not JJJ, so what will I do? I go to this and then I say if list dot contains JJJ, I say list dot remove that JJJ. So if I need to do something, any action or any kind of operation on my collection object, I use the relevant methods and I write my own logic and implement it. But in Java 8 streams, it is telling like you can give me any number of operations. I'll execute together and give you final result set, and that can be written in a single piece of line. So how do I do that? So what is actually this? So there are two kind of operations you can do. One is terminal operation. Another one is non-terminal operation. So the terminal operations will have an end. Okay, the non-terminal will not have an end. It is like it connects multiple methods together. So that is the reason these are terminal and non-terminal. So what are those terminals? So let's go with the same example, list. And if I use stream, so what is this stream giving me? It's a default method again. This, if you see, this is a stream, is again what? It's an interface. So what is this stream? So where this stream package is coming from? This is again in your util under stream reference. So this stream is again like specific to your data types. You have all streams like long, you have for string and everything. For all your data types, you have the relevant streams. And based on that stream, it can perform n number of operations. So all those operations will be done sequentially. So whatever value. So if you see here, if I need to filter, if I need to get the count, or if I need to find the first element, or if I need to convert that list to some other map object, or if I wanted to get the maximum from it, or any kind of operation, you can actually sequentially add all methods together in the stream and finally get my data. So I'm going with filter, and this is giving me something called predicate. So in the stream is basically like you perform a sequential or a list of operations to achieve some kind of result, and everything can be done in a single line. That is a main advantage. So you can handle n number of operations. All your aggregate operations can be done in a single way through your stream handling. So if you have any kind of stream, there's something called predicate. Have you ever come across this predicate in any context? Like, what does that mean? You remember?
Like prediction or something?
Sorry, guys, I did.
Oh, yes, please.
So anywhere did you come across the word predicate, and then have you ever, like, either in English or anyway, whatever context it might be?
In grammar, subject predicate.
Yeah, exactly. So what does that mean? So if you want to fly, if you would like to fly, you have to do this, something like if conditions, right? So basically, if it happens, this is going to be the end scenario. So it's like more of clause and subordinate clause and main clause. The main difference would be there in that. The same way in this predicate, if you want to do any kind of Boolean operations in case of if and else, and you're expecting only one result, and it will not return that result, it will just give you the output, but it is not something is returnable. It is like end, that if this is if for example, if my condition x is greater than 100, then you have to do this action, else you have to do this action. It's like terminating. I can't go further, this I can't do anything more than this. But in case of if I'm getting maximum value, I can get maximum, and on top of that I can do one more operation of average, and on top of that I can calculate percentage, and on top of that I can say like a discount, so something, right? So if I need to do multiple operations, then I go with aggregate methods. If I want to end that kind of operation, then it is a non-terminal operation. So this predicate is basically a Boolean expression where it tells either this or that, and then it gives you a final result. That's it. And you are not dependent on that result to do one more operation on top of it. This would be kind of an end. So in our case example, if I'm filtering it, so how do I give the representation of filter? So this expects a predicate. So this is again an interface, which is again a functional interface. So obviously you'll have only one public abstract method. So if you see, this is a Boolean test method. And if you see, and it is a default method. If you see negate, it is default. If you see the other one, or it is default. Okay. And the final is equal is again a static. So the only method which you can reuse in your lambda expression is test method. You can't use any other method because this is the only single abstract method in your predicate interface. So you can use only this thing to evaluate any kind of expression over here. Okay, so to do that, again, you have to go with the representation of lambda. So here the predicate test is returning what? Only one output, and it is accepting only one output. Sorry, one input. So how can I represent? So I represent some example result, and this result dot equals the object jjj. All match, and then again predicate. So what is happening every time? I'm giving one more condition and the filter. So everything is happening within that filter, and post that I'm doing the relevant operation. So if it contains jjj, I can just simply say collect Okay, so what I'm doing, if it contains, I need to do some action and then collect it. Right now, I'm just checking if it contains, filter it. So if it doesn't contain, okay, if it doesn't contain, collect it. And what does this list returns again? It is nothing but it returns me again list object. So I can just print the same list here. So if you see, it removed that relevant JJJ and it gave me the final list. So if you want to do the same thing in Java 7, what would you do? You write your entire condition and then you print your list. So there were like 2 lines of code, right? Now there is like nothing like that because the function interface, you know, this is the only method which you can access. So whatever condition you do, that is going to test it. So here the predicate test is nothing but whatever condition you do, it evaluates your result. It can be if condition, else condition, anything, but the predicate is going to finally do only test. So it tests your result, and if it checks like not equal to JJJ, then collect and then return it. So this is the way your list actually performs. So this kind of stream handling is provided only in Java 8. So you can hear this about predicate. There's also something called consumer and predicate. So this is a kind of relationship we see. So in terms of predicate, you might not collect it. Whereas in terms of consumer, you can collect your result and on top of it, you can do further operations. So this is a vast topic. So we'll see one by one on this. It will be little confusing as well. So if you have any questions, you ask me there itself. And the second thing which we learn is optional interface, which is again, which helps us to identify the null checks and then handle it better using our optional interface. There's something called date time API. So usually when we need to use date, what do? Is we create our own date from our Java util. Okay, or Java SQL. If you're working with JDBC, you go with SQL, or if you're working any database, you go with SQL. Otherwise, you go with util date. So you give this relevant date, and then you create a reference, and then you say date dot. Okay, let me create new date. Okay. So if you want something, you create usually like this. But the format of how you want your data, if you want to represent is MMDD YYYY, or if you want to represent in some format like MMM hyphen DDD, DD hyphen YY, and followed by your hour, followed by your minute, followed by your second, and the zone. So something like this representation. So what you do, you on top of that, you use your calendar interface using your factory pattern or through singleton pattern. You create your instance, and based on that instance, you convert the relevant format of how you want. But this is like a kind of how to say, a boiler piece of code where the user, the developer has to write every time wherever he deals the date concept. So what the Java 8 gave us is there's a framework called date time, that is Joda date time, that is coming from the let me show you in that different way. So this org Joda date time needs a dependency which comes again from the relevant Java API. So if you wanted to use the relevant thing, right? So what do? We have something called so you see here, there is something called date time. So this date time is coming from org Joda time date time. So this is a package which is coming from a represented package called Joda time artifact. And from that, we use all our date time related things. So what is the benefit of using this date time is you can instantly use anything, any kind of date operations, any kind of chronological order you want, or any kind of format you wanted to parse, or if you want it as a string, or if you want it as a date time, or just a date, or just a time, or any with time zone, or if it is a daylight saving or no daylight saving, any kind of thing, everything we have all the built-in methods readily available. So we just need to use this package and use them. So this is something which has been enhanced using Java 8 by the relevant Oracle team, and that is giving really a benefit to the developers to create any kind of logic on top of a date and time related activities. So this is again something which has been enhanced or created only in the Java 8 version. So we'll see more on this Java 8 date time, but before that, we'll understand the predicate consumer part more better using our Lambda expression. So today we see what is functional interface and how can we access that functional interface using Lambda expressions, and in going forward, how are we going to perform the stream multiple operations on your collections. So the stream is something you can use only on objects, okay, only on classes or objects, and not on any primitive types as you do your collections. So collections are again like you can't do it on your primitive objects, primitive data types. You can do only on the relevant wrapper types. The same way the stream also works on only on the objects and not on any kind of primitive things. So any questions so far? Janaki and Kriba, you have any questions so far?
No, sir.
Okay.
Okay.
Yeah, okay. So I'll wrap the class for today here, and tomorrow we'll continue again on the streaming part. Before that, I want you guys to just go into the comparator interface. Okay, so there's something called functional interface. I wanted to explore more on this functional interface from this package Java util, so that you'll get an idea like where exactly the functional interfaces are present. So, and it's a single abstract method. So I want you to figure out like what are the other functional interfaces from the util, or you can also check from Java util stream. From these two, you can name few like whatever you you come across.
Yes.
So we'll connect tomorrow by 8 again.
Yeah.
Yeah, I'll upload this video by tomorrow morning, Kirba, or if possible by tonight, and I'll let you know once it's done.
Yeah. Okay.
Yeah.
Can you upload that Monday class also?
Yeah, Monday class is already uploaded. I'll make it public. Yeah, I'll do that. Thanks for joining. Have a great day.